This section could just as well be in chapter 6, which is our next chapter, as it is in this one. Okay? So, but we'll do it.
This is where we introduce I.
Yep. Okay, so complex numbers. All right, that's going to be our little topic here. And complex numbers is just the imaginary number which is defined as the square root of -1, and it's symbolized by an I for imaginary. I don't know why they call them imaginaries, by the way. Okay, but I is equal to the square root of -1. All right? And the complex numbers are all the real numbers equals all the real numbers and imaginary numbers together. You like them?
Oh, yeah, you heard that?
Yeah.
Oh, yeah.
Man. Okay. So what does that look like? Well, anything in the form a plus bi, where a and b are real numbers, is a complex number. So 3 plus 2i, 4 minus 3i, the square root of 2 plus I, and just regular old I by itself. These are all examples of complex numbers. Okay? And they have applications in electricity, and there's one other thing, but I can't remember what it is. Okay? But they do have some real-world applications. So, this is called, this would be the real part. And this would be the imaginary part. But I'm not going to ask you that on a test. So the real part's just basically the number that's by itself. The imaginary part's whatever is attached to the I. So those are complex numbers. All right? And all they want you to do with them is perform some operations, which is what I put on the test review. And powers of I, and that's pretty much it. Okay? So, the first thing we're going to do is, I think they're going to call that simplify. Let me double check to make sure. They use I to write the expression. Okay, use I to write an expression. Sounds kind of complicated, but I'll show you what it looks like. So if we have the square root of -10, we're going to write that as I root 10, because remember that this can be equal to -1 times 10, and the square root of -1 is I. And that's where it comes from. Okay, so whenever you have the square root of a negative number, which you've been told you can't do, even by me, but I always was careful to say it's not a real number, which it's not. Now you can, because you have i's. All right. So anytime you have the square root of a negative, say 30, we just say this is I square root 30. All you're doing is taking the negative out and making it an I in the front. Okay, that's basically it with that. If you have 2 square roots of negative 32, then that would be 2I square root of 32, but can you break that down? What's that break down to? 16 and 2. And the square root of 16 is 4, so that 4 is going to go out there. That gives us 8I square root 2. So not a whole lot of stuff changes as far as our properties with square roots or anything. It's just there's just an I there. Questions on that part? Okay. Let's do some operations with them. Let's make them complex numbers. All right, so let's start with addition. I'm going to put parentheses around here just to separate the term, the two complex numbers. All right, 3 plus 2I plus 4 minus I. You treat I as if it was a variable in this case. So you're going to add the common terms, real parts, imaginary parts. What would we get?
7
Plus I, yeah. So adding them is just adding up the real parts, adding up the imaginary parts. No earth-shattering things there. Oops. I mean to subtract these ones. So, here's one, here's the other. We're just going to subtract them. We want to combine the ones that are like. So we have a 10. Oops, and we have a minus a negative. So what are we going to get there? 18. Very good. Then we have a minus 3I minus a positive I. So what do we get there? Now we have a negative 3 minus I. Right, so we have a negative 3 here minus that one I gives us how many I's? 4, right. Okay. So we're just combining the like terms when you're adding and subtracting. Adding and subtracting complex numbers is pretty straightforward. It even shows you that you can do it on a calculator, surprisingly. Kind of surprised. What would this one be? Yep. Yep. Combine the ones that are the real parts and the imaginary parts. That's how you add and subtract them. Questions on how adding and subtracting on those? Okay. Multiply. You'll see this too. It'll make sense to you. What do you think you do with those? If the I is a variable. Foil. Yep, foil it. Okay, so let's foil this. I want to step through it. 2 times 4 is going to give me 8. This is going to give me a plus 4I. This is going to give me a minus 12I. Here's the tricky part. That's going to give me a negative 6i squared. Okay? So, really, multiplication, we're just foiling, and it doesn't look like it's really, there's just one little tricky part to it, and that is right here. And the reason for that is because we have to think a little bit. I is equal to the square root of negative 1. So if I square it, what would be the square of a square root of negative 1? Darn close. Negative 1. Because all that squaring is doing is wiping out the square root. Okay? They're canceling each other out, leaving us with whatever on the bottom here, or whatever underneath. So I squared is just equal to negative 1. So what happens...
You just turn it into 6.
So what happens is, all you have to do when you have an I squared is change this into the opposite sign, right? So then we would have 8 plus 4i minus 12i plus 6. That's all you have to really worry about. So I squared is just negative 1. So all it does is flip that sign. Now we got to, finish it though. So we get 14 here and a minus 8i there. I got to make sure we finish it. So let's walk through another one. Okay, so here's another one. All right, we're multiplying, so we're going to FOIL. So I'm going to step through it. So there's my 3. There's a negative 3i minus 2i plus 2i squared. But what's that 2 going to become, really? Yeah, this is good. This is already a plus 2. So that 2i squared is really going to become a negative 2. Okay, because I squared is negative 1. So it's just going to change that sign. Okay, so now our common things, we have this and we have this. So that's going to give us a 1. And then we have these things in the middle here. What is that going to give us? Minus 5i. Okay, there we go. So with FOIL, the only tricky part to foiling is I squared is going to be negative 1. Let's just do one more for good measure. If I'm whipping through these kind of fast, just let me know and I'll stop. Okay, so we're going to FOIL this. What are we going to get? Let's step through it. So we're going to get 4 minus 20i plus 2i minus 10i squared, which is really just plus 10. Okay, so what's our answer?
14 minus 18i.
Yep, there it is. All right. So multiplication is not, none of these operations have been really difficult. I mean, with foiling, you just got to make sure you know I squared is going to be equal to negative 1. Any questions on multiplication before we take on division? Okay, we're going to take on division. I'm just going to start with a simple one like that. 3 divided by I. What's I equal to again?
Negative 1.
Square root of negative 1. Can you have a square root in the bottom of a fraction?
Nope.
Nope. Do you remember how to get rid of it? Multiply it. Good. Guess that. That's what you're going to do here. Okay, so we're just multiplying the top and the bottom by I, so we get rid of it. Can't have a square root in the bottom. What are we going to get on the top of this fraction? 3i. What are we going to get on the bottom?
1.
-1. So it'd be -3i. Remember, I times I is I squared.
Is it negative 1 times negative 1, 1?
I times I
Uh,
is I squared. Okay.
okay, got it.
Got it. That's how you divide them. But that was a simpler one. Let's look at one that's a little bit harder. Let's do one like this. Okay? Now, remember, though we did something like this, and it's actually one like this on the quiz we took on Monday. This is just a square root, right? Okay? So what would we multiply the top and the bottom by?
3 minus square root.
Really close. We went 3 plus the square root. Now, these are called conjugates. So when he's talking about conjugates, and it might talk about conjugates in your assignment, all we're doing is flipping the sign between the two real parts and the imaginary part. If it's minus, we're flipping it to a plus, and if it's plus, we're flipping it to minus. And we use it when we're dividing these. And the reason for that is, when we multiply the bottom of these and we FOIL, so we get 3 times 3, which is 9, and then we go 3 times 1i, which is, what's 3 times 1i going to be? 3i. Watch what happens. When we take a negative I times 3, that's going to be minus 3i. What happens to our I terms? They cancel out. That's why you multiply by the conjugate, because that gets rid of those I terms. But we still have I times I. So what was that again? -1. Okay, so this is kind of, so we have a negative I squared, which is -1. So that means really we're going to get, instead of being a -1, it's going to be +1. The sign's going to flip. Because it's a negative I squared, so instead of being negative, I squared makes it positive. So on the bottom of this, all we get is 10, because these go away. And it's designed to do that. That's why you multiply by the conjugate, and so those I terms go away. Okay? That's why we do it. The top doesn't matter. We can just work on that. So let's just work on the top. So what are we going to get on the top here? 6 plus 2i plus 3i plus I squared. But that is really just -1. So what are we going to get on the top as a final answer here? Close to 5 plus 5i. That all could be reduced, because 5 goes into those things. So 5 goes into 5. 5 goes into 5 once. 5 goes into 10 twice. There's our answer. So to review, when we have a situation like this, we're multiplying by what's called the conjugate, which just changes that sign, top and bottom, and the I terms are always going to go away. So the only thing you really got to multiply are these two things, because your I terms they're going to go away.
Why does the I squared on the top equal -1, then I squared on the bottom equals 1?
Well, that's a good question. So we have, on the bottom, we have a negative times a positive, which is a negative, right? So it's a negative I squared. So the I squared is going to change that negative to a plus. On the top, we got a positive times a positive, right? I squared. So that means it's going to change it to a, okay, flipping it on and off like a light switch, right? On, off. That's what it's doing. Okay, so let's try another one. 4 minus 2i over 1. Let's do 1 plus 4i. Okay, so here's our other one. We're dividing these, which means we're multiplying by 1 minus 4i, right? That's called the conjugate again. Okay? So the only thing on the bottom we have to worry about, because those I terms are going to go away, is those two things. Okay? Everything else is going to go away. So 1 times 1 is going to give us 1. 4 times 4 is 16. It's a negative 16 now. So it's going to change to positive, right? Because it's negative 16i squared. This I squared makes it negative. So now we have a plus 16. Okay, so here I'll move that up a little bit because I see some people kind of trying to find. So 1 times 1 is 1. 4 times 4 is 16i squared. But the I squared becomes like a on-off switch, so it's negative, so we're going to make it positive. We're flipping it, from negative to positive. Okay, bottom's done. Now we just got to FOIL the top. What are we going to get on the top? 4. Keep foiling.
Minus plus 16i.
Why is it plus 16i?
I get plus 8.
Oh, minus 16i.
Minus 16i.
Minus 2i.
Minus 2i.
Plus 8.
Plus 8i squared. But that really means we're going to have a negative 8. Okay? So yes, it's a plus 8i squared, but that changes it to a negative 8. Okay, so I got 17 on the bottom. And what do we get on the top?
Negative 4
Negative 4 minus
minus 18i.
18i. I can't reduce anything there, so it's done.
Why do we get negative 16?
Here, right here?
Yeah. 4.
So we're taking 4 times negative 4i. Who's asking me this?
Oh, never mind.
Oh, okay. So 4 times 4 is negative 16. I have this.
Never mind.
Okay.
No, it's the same. Right. And then
Do you want another one of those? Yes or no?
Sure.
We'll do this one. Okay. What are we multiplying this by?
1 minus I.
Can you move it up a bit? Yeah.
Yep. Okay. What do we get on the bottom? 1. No.
You get
1 times 1 is 1.
minus 1, but then you flip it, so plus 1?
So it's a minus I squared, right?
Right.
Then we got to flip it so it's a plus 1. Yep. So 2 on the bottom. Okay. We don't have to worry about anything else because the I terms cancel. Okay, what about on the top? Boil it out. 3
Minus 3i.
minus 3i minus I plus 1, but really it's a minus 1. All right, I squared again. It's going to change it. Okay, so what do we get for a final answer on the top?
2 minus 4i.
Oh, but that's not our final answer because we can cancel everything, or we can do some stuff here. What is this going to look like?
1 minus 2i.
1 minus 2i, yep. Done. Okay. Whew. So that's operations on complex numbers then. All right. And so that same idea, not to confuse anybody or anything, but this was a pretty common mistake. It's the same idea. So what would we multiply the top and bottom of that by? No,
No, the
3
whole thing.
plus the square root of 5. You got to do that whole conjugate, just like it's a, okay? Not just the square root of 5, because that's not going to cut it, because you're going to have to go here and here. All right, so make sure you're always using that conjugate when you have something like that. Okay.
1, 2, 6, 7, plus.
Where?
So it cancels out.
Oh, because it's the conjugate, and that's going to get rid of the square roots.
The conjugate bit cancels the reciprocal.
Okay. Let's see. I want to do one more thing. Powers. I is equal to the square root of negative 1, and I squared is equal to negative 1. We said that, correct? I cubed is the same as I squared times I. Would you agree with that?
Tell us it is.
No. I cubed is equal to I squared times I, right? Because what is that?
Squared is equal to negative 1.
Yes.
Both, and because we add the exponents, we get I, right? Okay. What's I squared equal to? Negative 1. So I cubed then is equal to negative I.
Wait, is that one squared or I squared?
That's an I squared right there, and this is I.
And that's I.
So the whole I cubed is negative I. I to the fourth would be equal to I cubed times I. What did we say I cubed was equal to?
Negative I.
Negative I times I is negative I to the second, but I to the second is,
Negative 1.
which means that I to the fourth is equal to, not negative 1,
Oh, 1.
1.
Oh my god.
Oh my god.
Now watch. It's going to get good.
No, it's no.
No. Can we just put overhead?
No, but it's going to get good.
No,
I think we need to
on you.
redefine your words.
Yes, we need to rethink this.
No, it's going to get good.
This is like me telling my kid, wash the dishes. It'll be good.
Yeah.
You.
Builds character.
You think it's good, don't you?
I feel like this is becoming very meta.
Okay.
Oh my god.
I to the fifth
Uh,
is equal to I to the fourth times I. Watch this. I to the fourth is what, though? We just figured it out. 1 times I is I. So I to the fifth is I.
oh, yeah.
Yeah, you still don't think it's good yet, do you?
Sarcasm.
We get to keep
So where's the good
Notes
part?
during the
we
test.
Now
get
watch
to
what
use
happens,
this
though.
piece,
We
right?
get
I'm
to
telling you,
keep this on
it's
the
really good.
index card for the
I to the
test,
sixth
right?
is going to be
It's I
equal
times
to.
I.
Negative I.
Is he close?
Negative 1.
Exactly. Exactly. It is.
Oh, so it starts over, right?
So it starts over. See?
yeah.
point?
It's so good.
This
so
is good. I to seventh, it starts over. So what's that one?
No.
Wait.
I
That means I to the seventh is negative I.
Negative I.
I to the eighth is 1.
I to the eighth is 1.
I to the ninth is I.
Yeah, so it starts
I to
over,
the
right?
10th is negative 1.
So here's the deal. Watch this.
Spectacular.
I bet you could find I to the 101st power.
Yeah, just keep that.
It would take a lot.
It would take
No, it
a lot
wouldn't.
of paper.
How long does it take to repeat?
5.
How many powers does it take to repeat?
6 to
6? No, it repeated.
5.
Nah, it repeated before.
Yeah, 5.
1, 2, 3, 4.
Oh.
Okay? Then it starts to repeat. So, if we take 101 divided by 4, 4 goes in there
25 times.
25 times, leaves us with a remainder of.
1.
So what is it?
Negative 1.
No,
1.
it's I.
Oh.
Wait, what?
Because its remainder is 1, right? It cycled through there 25 times, gave us I.
I got
See? There we go.
I know, but you have a remainder of one, so what do you do?
Right. Well, that's I to the first. What's I to the first? I first is I. Okay? What do you mean you're done? Stephanie? No, Stephanie.
I thought I was -1. I'm so confused.
Well, I is equal to the square root of -1. Yeah. Equal to the square root of -1.
-1 or I?
Just count through them all 101 times and whatever you land on.
Oh, you just gotta divide it.
What is the
Okay,
power
so
of
show the whole thing without any.
I is equal to square root of -1. Yeah. Okay, moving on. Okay. How about I to the 67th? What would we do with that? 67
Divide by 4.
divided by 4. 4 goes in there.
1
I had
time.
it on my 64 when I had one.
Yeah, 16.
16 times with a remainder of?
3, or, no.
Yeah, remainder of 3.
So it's -1?
So then what's I to the third is?
-1?
I. There he is.
I get it!
You got it, yeah. Yeah, you just look at the remainder. That's all you got to do.
Well, you should have said that from the beginning. I was trying to figure it out on the other.
Yeah. That's what's really cool about those powers of I. Well, for some people anyway. Yeah, divide by 4 and then you don't care. You just look at the remainder, right? Yeah. That's all there is to it. So that's all there is to the complex number stuff right there.
Why don't the other ones are the same thing?
So it starts to repeat every 4. Okay? So,
So if we wanted to do it on our calculators, where would we find I on an 84?
I think it's on there. I'd have to look.
Well, I'm sure it's on here too. It should be used.
You
Oh,
just
there
use-
it is.
You just use a letter.
It's on an 89.
Yeah, I found it. It's second and then I blue.
Mm-hmm. Yeah, it's on there someplace, I think. Okay. But you gotta have I don't think it's gonna work on any just a calculator. It's gotta be like a,
I have it.
yeah,
What
I know
if the
that.
remainder is 0?
Well, what would that be then?
Four is-
It would be just,
The fourth one.
it would just be, what, 1?
1. Yeah. Yeah. So that's cycled through everything more, yeah. Mm-hmm. Yep. It would be 1.
That was good.
Thank you.
That's good, huh? See?
Yeah, that
Yeah,
was good.
that's good. Yeah, it's good. It even gets more interesting, but that's higher power mathematics. All right. So anyway, that's all I got. Now, if you have any questions on the review or anything else, I am going to stay right here.
Do we have to stay right here too?
No, this is your opportunity to do what you want.
We don't know?
Well, some of us are.
You have to stay here, don't you?
Well, I'm not going to stay here if you guys all leave, but I'll stay here as long as people ask questions off the review or off their test that they took that they're not sure about how to do square roots.